guys, so today I'm going to go over part of Big Idea 7 Standard 1, which is drawing heating and cooling curves. So where students lose points when it comes to drawing heating and cooling curves is they forget all of those good graphing techniques. So first, we need to label the X and Y axis with the appropriate variable. So you have two options for the X axis. We can either label it reaction progress or energy. Most students use energy. I usually use energy, but you can also use reaction progress. If you use reaction progress, your units are going to be some variable of time. So let's say we were recording temperature readings every 10 seconds. We would put reaction progress along the x-axis, and in parentheses we would put seconds. The y-axis is always going to be temperature in degrees Celsius. So we want to label the x-axis with energy, we want to label the y-axis with temperature, and then we also want to make sure that we include units for each axis, which I did. So we record energy in joules and temperature in degrees Celsius. Next, the x-axis does not need a scale, but the y-axis does, and it needs to be an appropriate scale. So a few mistakes that I see. Some students will just draw their heating curve really quick like this, and then mark this at 175, and mark this at 50, because that is my melting point and boiling point. Well, that's not a consistent scale. We have a nice piece of graph paper here, so we want to use it. So make sure that your scale is appropriate and make sure that it's consistent. So we want to go up by the same number every time. Another mistake that I see students make is sometimes they want to start their scale at the melting point and end it at the boiling point. Well, it plateaus at the melting point and it plateaus at the boiling point. So if you used 50 and 175 as the start of your scale and the end of your scale, you're not going to have any room on your graph to show when the substance is a gas or when the substance is a solid. So a few tips. First, we want to make sure that the scale always starts below the melting or freezing point, depending on what you're given. And then the scale must end above the boiling or condensation point. A tip. What we can do is count the number of lines that we are given in our graph. And there are 25 of them. Next, we want to think about what our scale should start with and what it should end with. Well, it needs to start somewhere below 50. So I'm going to start mine at 0 degrees Celsius, and it needs to end somewhere above the boiling point. So it needs to end above 175. I'm going to end mine at 250 degrees Celsius. That means that the y-axis needs to scale a total of 250 degrees Celsius. So I can take the number of degrees that I want to cover, divide it by the number of lines that we have, and that will tell you what each line represents. So my scale is going to increase by 10 degrees Celsius. So now I have an appropriate and consistent scale. It is consistently going up by 10 degrees Celsius, and I am going to use the entire piece of graph paper. We wouldn't want a scale so small that your whole curve fits in a very small portion of it. We want to use as much of the graph paper as possible. Alright, so once we have our graph drawn with our axis, our labels, our units, our scale, now we can go ahead and draw our heating curve. So for heating curves, we know the temperature is going to increase over time. So I'm going to start down at a low temperature, and my substance is going to increase in temperature until it reaches the melting point. Once it reaches the melting point, it's going to plateau because it takes time for it to melt. Think about if you had an ice cube. It's not 100% solid at 1 second and 100% liquid at the next second. It takes some time for it to melt. So the plateau is representing the time or the amount of energy that it takes for that substance to melt. Once it melts and it's completely liquid, that liquid is going to increase in temperature until we reach the boiling point. And again, once we reach the boiling point, we have a phase change. It is going to plateau. And then lastly, my substance is going to continue to increase in temperature. So my heating curve looks something like this. You should be able to label each section of our heating curve. So down here at the lowest temperature, it is going to be a solid. The solid melts into a liquid, and then the liquid boils into a gas. Alright, let's say we had the exact same substance, but instead of drawing a heating curve, we needed to draw a cooling curve. So the only difference for a cooling curve is that the temperature is going to decrease over time. Remember that the condensation point is going to be the same as the boiling point. So I'm going to start up at a high temperature. My gas is going to decrease in temperature until we reach the condensation point. Then it's going to plateau. Once it turns into a liquid, that liquid is going to decrease in temperature until we reach the melting or freezing point. Melting and freezing take the same amount of energy, so they occur at the same temperature. And then lastly, the solid will decrease in temperature. We should be able to label this curve as well. So at a high temperature, we have a gas. The gas will condense into a liquid. The liquid will decrease in temperature until it reaches the freezing point, and then it will freeze into a